Hello, I'm out with the flu, but now I'm back. So it's time to talk about regression, the good parts. This is amazing to me because there's a book called JavaScript, The Good Parts. 5 things. It's going to be a short video to start off with. There are 5 simple things I'd like you to start off with about simple linear regression, and that is predicting the score on one variable, the criterion variable, from another variable. Say you wanted to predict GPA from the number of hours a week students studied. So that would be an example of linear regression. You have 2 numeric variables, and one of them you're predicting from the other one. Errors of prediction, residuals, are the difference between the predicted value for a subject and the actual value. Take a little bit closer look at that in a minute. Regression consists of finding the best fitting straight line. That'll come back in another video. The best fitting straight line through all the points, and that's the regression line, not surprisingly. The best fitting line is the one that minimizes the squared residuals. Now, remember, residuals are the difference between the predicted value for an individual subject and the actual value. Why squared? Because the sum of the residuals is 0, as you will learn in another video. And if you think back to very early in the course, we found the sum of the deviations from the mean was 0, but then you square them, add them up, that's divide by n, that's the variance, take the square root. So anyway, the best fitting straight line is the one that minimizes the squared residuals. And the regression equation is this: the predicted y equals a plus b times x, also shown like this. The sum of squares, you'll see this come up a lot. It'll come up in another video. The sum of squared difference from the mean divided by n minus 1 equals the variance. The sum of squared errors divided by n minus 1 equals the error variance. So sometimes we just skip the step of dividing by n minus 1 and compare the sums of squares. And variance, I will say this a bunch of times, can be divided into 2 parts. A statistics professor I liked a lot would say that science is the search for explained variance. We want to know why some people get higher GPAs than others, why some people make more money than others, why some schools have lower dropout rates than others, whatever. There's variance in the world, and we would like to know what explains that. So predicted variance is the difference from the mean predicted by the predictor variable, in the case of linear regression, or predictor variables in other cases. And the error variance is the difference from the mean that was not explained by the predictor variables. So that is the sum of the squared residuals. So let's take a look at how this works. If we have no predictor variables at all, and this actually comes from a data set I have on the number of grants that faculty members get. And the mean number is 1.14, the mean number that any faculty member would have at one time. So the predicted value, the predicted score would be 0.53 plus 0.08 times x, where x is the number of grants they had in their career. So I'm trying to predict the number of grants a person has at a particular time by the number of grants they'd had in their career prior to that. Now, Bob's score is 20 here. He has gotten 20 grants in his career prior to that, and at his current institution right now, I would predict that he would have 0.53, this is A, plus 0.08 times 20, which would be 1.6, or 2.13 grants. Bob's actual score, the actual number of grants he had in his current institution, was 6. So 6 minus 2.13 squared equals 14.98. 6 minus 1.14 squared equals 23.62. Now, as I said, if we didn't know anything about Bob, we would have predicted that his score would have been 1.14. Don't know anything about a person, your best guess is the mean. So 6 minus 1.14 squared is 23.62. So that would be the total variance. Now, we predicted his score would be 2.13 based on our knowledge that we had of the number of grants he'd gotten in his career so far. So 6 minus 2.13 squared equals 14.98. So there's still some variance. The difference, remember, between the predicted score and the actual score is the residual variance. And the difference between the 23.62, which would have been the variance if we used the mean, and the 14.98, which would have been the variance if we used the knowledge of our predictor variable, that difference is 8.64. And that is the amount of variance explained. So explained variance. And so in this case, we've explained more than a third of the variance in the number of grants somebody has at the current institution by knowing the number they had in their career previous up to this point. And that's one reason, say, if we were hiring faculty, we might give a lot of priority to those who had gotten a lot of grants up to now, if that's something that was important to our institution, because it's a good predictor of how many they're going to get for us at our current institution. Let's take a quick look at the regression line before we end this video. A is where the regression line intercepts the x-axis because it's a plus bx, and if x is 0, right here, then the value of y is going to be a. And b is the slope of the regression line. If the relationship between x and y is positive, then b is positive. For example, the number of grants that you had, and that's exactly where this came from, the number of grants you had in your career up to now, and the number at your current institution. So here's my predictive variable x. Here is my criterion variable y, and you can see by this line that there is a positive relationship. If the relationship's negative, then b is going to be negative. And if there's no relationship, then b is going to be 0. And that is a real quick introduction to regression and the regression line and sums of squares and residual variance. We'll dive into a little bit more in another video.